We're waiting for one more panelist, or a couple more panelists at the moment. A key panelist, actually, should I say. So if you bear with us for a few minutes, thank you. Okay, good afternoon, everyone. Welcome to this session on the Internet identifiers and how the DNS will function in a smart cyberspace. Very interesting topic. I'm glad to see so many people here. I am not Wolfgang Kleinwächter. Fortunately, he was not able to come due to a few issues, so I'm stepping in for him. My name is Olivier Crépin-Leblanc. I'm the chair of the European at-large organization and several other hats as well. But today, I'm basically just an individual who will be trying to moderate this session. We've got only 1 hour. I think it's a very short session. We also have one panelist missing, and that's Vince Cerf. He's currently in another session. He will join us a little bit later. But we still have a star-studded panel here. And of course, we want to have as much interaction with everyone in the room as possible. So I'll ask everyone to be quite brief in their statements, etc. I think that we can just turn straight over to Jörg Schweiger, who is the proponent for this session and who's basically put it together. So, Jörg, you have the floor.
Well, thanks very much, Olivier, and welcome to this sort of impromptu show because everybody seems to be on time arriving. And we didn't very precisely come to terms with how this flow is really going to happen. So let me start with the key question. Can we keep the Internet open? Can we keep it secure, unfragmented, and transparently governed? I think these are the key questions of this workshop as new applications and services like IoT rapidly evolve and the usage of the Internet shifts more and more towards mobile, towards machine-to-machine communication. So are proven technologies used today, like DNS, for example, suitable? Do we need to adopt them or even substitute them? Or just in contrary, are those best practices, proven over decades, ready to use, only restricted by perception, know-how, and or political calculus? This is what we are discussing about, and it's a pleasure to do so from very, very different perspectives represented by distinguished colleagues from the technical community as well as from a commercial and a government-related standpoint. And I'm sure statements from you, the audience, would be very warm and welcomed as well, be it within the audience or be it remotely participating. So without any further ado, I'd like to hand it over to our moderator.
Thank you very much, Jörg. So we have, the session is structured with first a few speakers that will have about 5 minutes to bring their points forward. Then we'll have a handful of commentators as well. And then we'll open the discussion throughout the room. Our speakers today are Christoph Bianchi from the Donor Foundation, Marco Hogenwonig from RIPE NCC, Hans-Peter Dittler from the ISOC board, and I think, well, we should have Rami Ahmed Fati from the ITUT remotely, and we might be able to get him or not. We'll have to see a little bit later. But let's start first then with Christoph Bianchi from the Donor Foundation. Christoph, you have the floor.
Thank you very much. Welcome to all. It's a pleasure to be here addressing you. So 5 minutes is not too long to talk about what we have to talk about, but the Donor Foundation is a little bit of a black sheep, if I would say, in this community. There are all sorts of issues having to do with are we competitors to DNS or not. Our perspective is, however, different. We've been working on what we call the digital object architecture. Before, it was CNRI in the United States that pioneered the work with Bob Kahn and Vince Cerf. And now the Donor Foundation is taking the mantle of working on the standard and operating the Global Handle Registry, which is a different type of identifier resolution system than DNS. So a little bit about why CNRI and now DONA are pursuing the handle system. At the beginning, this was based on this notion that information on the Internet had to be a first-class citizen. So what does that mean? That means that every item that you can reference, whether it be physical, a machine, an IoT device, a person, it really doesn't matter, has an identifier that can be resolved securely into what we call state metadata. And the state metadata is something that is user-defined. Hopefully there's some standardization so everybody can understand a little bit what they're saying. But even if that's the case, they can type their metadata and somebody can walk through the typing system, which themselves are identifiers, to figure out what these things are. So we start with identifiers that are globally, uniquely, and securely resolvable. And then we put on top of that a data model that provides consistent access to any kind of information. So whether you're a server, whether you're an interface, whether you're a device, whether you're a file, you talk to these things the same way. Mostly it's you make a request using a type. This type is itself an identifier. If you see an operation with this type, everybody knows what it means. You can create new operations. If you want to create, give me your temperature, you can create a type that does this. And hopefully the next guy who has a sensor who wants to access his temperature can use the same type. But they're not restricted to do that. The reason, so I'll focus a little bit more on the identifier system, which we call the handle system. So it's independent of DNS. It was built completely separately. And it's not because, DNS doesn't work. It works great. That's not the issue. The issue was that we needed record-level granularity security. We needed scalability where the services could be run easily by anyone on the net. We needed to be scalable so that people could have one local handle server, as we call it, or 1,000, mirroring the same address space. And the interest was that every community running these services could set their own policies, operational regimen, and could respect their local laws. So the handle system is a resolution system. So you could say it's similar to what DNS does. DNS is a resolution system. People have implemented version of the handle system with a bind backend, or vice versa. You can have interoperability between the two. Again, the advantage of the handle system is record-level security. So you don't sign zones. You have individual access and administration on your records, and you can sign and certify those as you need. So overall, I would try to keep this short. The point of the handle system was not to compete with DNS. We think we can interoperate. We can interoperate with blockchain. We can interoperate with anything that needs identification. We have some ITU has implemented, for instance, OID resolution using the handle system. Our view is that we want interoperability. We welcome anybody saying, well, we like our identifiers. We maybe like our resolution systems, but we'd like them to be also accessible using the handle system because there's a large community that uses them. And a final point, we have to think about identifiers. The key point of identifiers is that you want to identify a thing. And this thing has a granularity that is independent of the model that you started with. We don't know what we're going to be identifying. We have to be able to identify anything, everything in the trillions. And each of these items need to be securely resolved, identified, described, so that you can interact with them. And those things could be dynamic. In China, they have building management entirely driven by handle system, where they can control pumps. They can figure out what's the RPM on those pumps, what's the temperature of the swimming pool. They can monitor base stations for cell phone towers. They have like about 5.5 million of those. They, full cycle supply chain management. They keep impressing us with their ideas. Counterfeit is probably one of the things that has the highest value, the bang for the buck. It's a local handle server with identifiers that have state metadata about the thing that you want to track through the supply chain. And so with those remarks, I'll conclude. Thank you very much.
Thank you very much, Christoph. And you've actually answered some of the questions I had for you already, but that's good. That saves a bit of questions before us. So now we've got Margot Hogewonik regarding, from RIPE. So when you're handling numbers, what is your approach to the enrichment of these options that you have now?
Thank you, Oliver. Quick. I work for the RIPE NCC, which is the regional internet registry for Europe, the Middle East, and parts of Central Asia. And one of our core duties towards the internet is the distribution of IP address blocks to users everywhere. Originally, I'm an engineer, so I kind of look at this very much from an engineering perspective. These days I do less engineering, it's more social engineering or wordsmithing, but the age-old rule there still, I think, applies, and that's use the right tool for the right job. And I'm doing a lot with IoT, and if you look into sort of the topic of IoT and identifiers, maybe some of you will say like, oh, here's one of those non-believers. To the topic at the panel, the DNS has served us for a very long time as probably the most crucial part of the internet. Nobody can remember IP addresses, and IP addresses have a tendency to change, and the DNS is really the glue that holds it all together. A name you can remember, a name you can tie to an address, and that you can easily type. So in that sense, I think the DNS is serving as part of the most fundamental part of the internet. It allows us to find everything. Until then, Google took over. But closer to home, and then what I do is I'm internet numbers, and I'm very deep down and kind of on the invisible side of what makes up the internet. But in essence, if you want to connect to the internet, you need to run the internet protocol, and in the global space of what we call the internet, you can't function without using one of my or one of our colleagues' numbers. If you don't have an IP address, it's impossible to use the internet protocol, and from an engineering perspective, it's impossible to connect to the internet. You might connect to a global network in some means, but yeah, is that still the internet or not? So a bit more towards what Jörg said in his panel is like what we're trying to answer here is can the existing technologies, DNS in particular, but maybe also IP, keep up with the changes to come, also from a government's perspective. And certainly we have challenges. I've run out of IPv4 years ago, so did my colleagues. And our industry, the collective, as we sit here, have only done that much on rolling on to IPv6. There's still a lot to come. Also what I see a lot in IoT is especially for people developing low power, long range, battery operated sensor networks. IP protocol, the internet protocol, isn't really popular. People see it as a lot of overhead, there's a lot of state to keep, and rather run without it. Because they don't see the added value of IP. And sometimes I have to agree there, because sometimes you look at applications, you think like, is it really that beneficial to have it sit out in the open in a number space where everybody can reach it? Or are we better off without? And of course, what we then have to look at is, can we match all those requirements? But also, do we want to match them? The DNS very much evolved from what it originally was to indeed having that global distributed database. Sometimes we're joking in the Internet Engineering Task Force is like, yeah, just put it in DNS. If you wanna load something into the internet, no matter what, find the DNS label, put it in there, and then it automatically distributes. It's true, it works. But it also poses governance challenges. And sometimes I wonder, like, do we really want to meet all those challenges, or indeed leave it to, well, call it competition, leave it to a better tool to do that job? That doesn't mean we need to abandon DNS, or we should abandon DNS, or maybe even we can abandon DNS. It will be there. It's part of the internet. It's part of, for us, to locate things. And we have to see it in a way that when you look into machine, they don't care whether it's a fancy name. Any hexadecimal string will do. In that sense, it's far less fancy, and people probably won't pay a fortune for having a beautiful domain name, because machines aren't going to type it. But crucial, and I think for this panel also to keep in mind, is what are you trying to identify? I very much keep telling people IP addresses are not identifiers, because we usually see them as, if I know your IP address, I know who you are. And that's not the case. An IP address identifies a network endpoint. You move your device in the network, your IP address will change. That doesn't mean you change, but you'll have a different number. So I always stay wary of connecting IP addresses with identifiers in this context. Yes, we are an identifier, but we're basically identifying the little antenna in your laptop, and that's all we do. You want more, you want other things. I'm not sure I can accommodate that within the current framework. We can, of course, look into your needs and see if we can change our framework and change the way the Internet Protocol currently works to match some of your needs. But maybe indeed we need to step back and say, like, okay, this is for somebody else. This is for a different layer of the Internet to solve. And whether you can use an existing protocol or invent something new, that remains to be seen. I'll leave it with that.
Thank you very much, Marco. So next is Hans-Peter Dittler from ISOC. And the Internet Society has made a statement about in the ITU WTSA recently about the DOA, Digital Object Architecture. Do you see DOA as being a problem or an opportunity? And as far as the future is concerned, do all objects need a handle? That's for Hans-Peter. And then you can answer that as well afterwards, Christoph. I think we know your answer already.
What a question. Yeah. So trying to come back a little bit to the title of our session, how the DNS will function in a small cyberspace, I could make my statement very, very short and sticking to just the same as it's been used for the last 20 years. But looking a little bit deeper, the position of ISOC is really to keep the Internet open, available, usable for everybody, everywhere. So we need to make sure that things like stability, scalability, reliability are still key points. And the DNS, as was already mentioned, is now in an age where you can really think back on a long time of evolution, and you can say for sure it's stable, it's scalable so far. But at the same time, new things have to be covered, and new developments need to be there. And also already been said more or less. Why has it to be done always inside of the DNS, even if you can shift nearly everything into a DNS record? Is it really the right way to do? So we have the belief that there are many possibilities to solve things, and there might better solutions to some things which are besides the DNS or on top of the DNS or somewhere else in the Internet. It doesn't need to be the same thing. But then we have to look very closely at the new development, and we have to look at it at a technical viewpoint. Is scalability, reliability, stability really proven? Is it there? Is it part of the whole development? We have to think about how secure is the system against tampering, against misuse, against stealing of personal information. All of those things have to be looked into and checked very deeply. And there are additional promises from new ideas in the digital objects architecture area, like permanent storage. Yeah, permanent storage, that's a promise. It's nothing more. It has to be proven over time that it's really permanent. You could also store things permanent in DNS. You can also store things permanent in a text file if you like. John Postel stored IP records in a very permanent way in his text files. So how permanent will it really be? And the second or the big area also mentioned by a previous speaker is about policy and transparency. What policies will rule those new regimes of identifiers, especially if you see that parts of this identifier space is given to different local organizations? Are they bound to some basic rule set or some basic policy set? How transparent are those policies, and who will check on those policies? I think there are still a whole load of questions which have to be answered before we can really jump on a new technology and promise that this new technology will solve all our problems in a defined set. It will never promise to check all problems, but at least in a defined set. Yeah, and your last question was, should all things in the world, all objects, have an identifier? I'm not sure. I'm not even sure how to define an object so globally that we are talking about the same thing on our panel, not talking about the room or the world. So I would be happy to attach an identifier to any object, living or dead, digital or analog, which needs to be identified, and then leave it there. Okay.
This is becoming very philosophical. This is not an object. So next, we were supposed to have Rami Abdelfati. Is he online or not? From the ITU study group 20, which is the applications of IoT and smart cities and communities. Do we have Rami on the? No? Okay, so then we can go straight to our commentators. We got two commentators. We've got Adil Aplogan from ICANN, and we have Olga Cavalli from the South School of Internet Governance?
From many places.
Many places, many different hats. And so let's start with Adil. What's your thought about DOA, the DNS, the future, how to address objects, etc.?
Yeah, thank you. A brief comment. I think the issue here is about how we evolve our the internet infrastructure and specifically the DNS to match with the application evolution, the use evolution, IoT, and so on. One thing fundamental is that we know the DNS. We have been using the DNS for the past many years. We know how robust it is. And it is one of the most distributed databases we have today, which is scalable, has proven several times its scalability. From my perspective, I think we are going to continue building on that, on what we know. And beyond the fact that today the DNS is seen as a way to link semantic name to IP address, we may move away from that semantic aspect of the DNS to other kind of mapping of identifiers. But behind, the DNS will always be used to resolve those type of name, even though they are not semantic. So we will see more and more information add to the DNS because people rely on not only the technology but the policy environment, rely on its scalability. And because it's already running, people won't go with something that will be so disruptive that they will start over. We have seen the example of IPv4 and IPv6. IPv6 is completely a new protocol which is not backward compatible with IPv4, which makes its adoption a little bit more difficult. And we'll see the same thing for the DNS. People will want to use the technology that is already there. The question is, how do we evolve the policy environment to match that evolution of the DNS? How do we make sure that the security aspect or privacy aspect of this is taken into consideration? When is the right moment to start thinking about the policy aspect, to not refrain the evolution of the technology or to come in later, as somebody pointed out yesterday? We have seen work done, I mean, specifically for ICANN. We have been looking into this, and we have, in 3 weeks, for instance, implemented some extension of the DNS to take into consideration that semantic aspect, that persistent identification in the DNS. It's doable. The main thing is to look at what is the issue and how can we do it without creating too much disruption.
Thank you, Adil. And next is Olga Cavalli. Olga.
Thank you. Thank you very much, Olivier, and thanks for organizing this very interesting panel, and thank you for inviting me. I would like to make some comments from a kind of different perspective, a disruptive perspective, is what happens in developing countries and developing economies about these identifiers. I'd like what Hans-Peter said about that the DNS is open and usable, secure, reliable. We know that, but there is an imbalance in between the developing world and the developed world. For example, if you check the usage of IPv6 and IPv4, for example, in Latin America, there is still a long way to go and to have a level of usage in like developing countries and developing economies. What I see now, and this is a perspective from me being a university teacher and investigating these issues from, especially from the Latin American perspective and from developing economies perspective, is that the changes are being more rapid now, and I see a gap in between the possibilities of developing economies in adapting and using these technologies, especially if we are going to create or use a different set of identifiers, say for example, for Internet of Things. How this will be governed, how this will impact the development of technologies in developing countries. For you to have an idea, half of the economy and half of the labor in Latin America is run by small and medium enterprises. How can a small and medium enterprise capture these technologies? Are they able to have human resources to learn how to use it, participate in the governing organizations about this? So this is the comment I would like to share with you. I don't have an answer, but you are perhaps more experts than myself and about these issues. And I see these technologies evolving very quickly. For example, we have a lot of development in the agriculture in Latin America, especially in my country, Argentina. And now the small and medium enterprises are trying to use Internet of Things and precise agriculture to enhance their production, to capture the demand that we will have in the future. Will they be able to do that? And Industry 4.0. I have been checking the strategies from Germany and United States, for example. They have built a strategy which is very much partnering the companies, the government, the civil society, different organizations, unions. Is that happening in the developing world? It's a question I have, and it's a concern I have, so I would like to share this concern with you. As I said, I don't have the answer, but just this is something that worries me from my citizenship being Latin America. Thank you very much.
Thank you, Olga. Would any of our panelists wish to address some of the questions that Olga has raised? Christoph? No?
I don't have much to say. I just want to echo this business of, what is the granularity of identifiers and what does it mean to be persistent? Clearly, persistence is an actively managed thing. There's no magical store out there that will remain, in eternity. So clearly that's not the promise of the digital object architecture. But the point is that it's the nature of the identifier itself. So make sure that the identifier does not contain any rules, regulations, approaches, algorithms that you may want to shy away from later on. We had a great case recently with one of our multi-primary agency administrators in Rwanda, where they wanted to take a prefix of 250 to match their country code for the phone. And then they realized that they wanted to also sell identifiers for the rest of Africa. And imagine a passport in Kenya starting with number 250, that just wouldn't work. So semantics is where you find it, where you make it. If you want something persistent, it better be completely irrelevant from any possible bindings to things that have to do with the physical world. But you can do things, with some level of flexibility. But if you really want persistence over time, you have to think, what is it going to be in 1,000 years? What are we going to do then? And this is what the DOA tries to wrestle with. It's being completely independent from the underlying technology. So you're left with just ways to interact with things, and on a very simple data model level that we think is enough to deal from the simplest to the most complex. And what binds this and makes this possible is this notion of interoperable, or should I say, extensible typing mechanism. So the core DOA is based with the notion of extensible types. So if you can't do something today, you create a type, it gets globally accessible, and you can extend your infrastructure. But the rest, the core remains the same. This is a principle from Bob, which I really like, is when you're defining a protocol, get rid of all the things that are redundant and just keep the core. You can always add niceties later, but the core has to be single purpose. And this is what the DOA is trying to do in the space of identifier. And more importantly, what do you identify and how do you deal with that? Thank you.
Thank you, Christoph. And I was going to ask if panelists had questions to ask to each other, but I already see people on the floor wishing to ask questions in the room, so that's pretty exciting. Let's start with Walid Al-Sakaf.
Yes, it's Walid Al-Sakaf. I'm a member of the board of the Internet Society Blockchain Special Interest Group, and one of the research areas we've been exploring is the potential for a totally decentralized DNS identifier system that would be totally distributed in a way that would prevent any form of central failing points or points of failure. Alongside that, there is also another threat. I mean, that's first, what's your opinion on that? And the other point is about the recent announcement by the, was it the Russian Council, talking about the backup DNS that will be set up by August next year in collaboration with other BRICS countries. How do you see this government intervention directly into a space that's more technical in nature? How would that threaten the current model, and whether this is simply a natural evolution of how things evolve in terms of technology, or it's a breach of the multi-stakeholder model?
Thank you, Walid. Anybody wishes to tackle these questions? Marco, you're brave.
Let me then be the brave one. Well, I admire some initiatives there in terms of, like, let's decentralize certain parts, in the sense that we probably need to be careful and look out for the single point of failures in the system. But we also have to be certain that from a technical perspective is a good objective, but from more political perspective, I can't see how we fully can decentralize the DNS, in that you need globally unique labels to some extent. So even if you would decentralize that and you allow people to generate their own labels, sooner or later we need a form of arbitration. And that form of arbitration becomes your central point, which is liable to capture and has difficulties. So in that sense, be careful what you wish for, because we have a working system now. We know what we do. There is a small, let's call it single point of failure in the sense the root. I think engineering-wise, we've done a lot to solve that with 13 root servers, all independent of each other. I, at current, don't see an immediate point where the whole of the root system will fail. But you need to allow your clients to also operate as designed. If you're going to restrict your clients to only use a specific set of servers, you are creating a single point of failure. And I think in terms of DNS from an engineering perspective, be careful what you're trying to solve and at which layer you're trying to solve it. Because if you want to solve political problems at the technical layer, you're likely going to end up with other problems.
Walid, I saw you shake your head a bit earlier. Was there anything that you didn't?
I mean, I was thinking of the Blockstack initiative, Blockstack DNS, and they actually have answers to those questions. So I was thinking of perhaps another session on this would be useful, but it's too much for now.
Next year. We've got a queue now in operation. First, I've got Jörg Schweiger, Alain Durand, and then over at the back. So, Jörg.
So even though Marco was already brave to answer the question, I'd try to answer it as well. I think blockchain is a very interesting technology. It's yet another alternative to cope with the problems we try to solve with DNS right now. I'm pretty sure other problems still need to be solved, like with DOA. And for that reason, I just would be cautious to figure out if we do have problems we want to solve, and if we do not just propose yet another new chain of technologies where all different kind of problems that already have been solved need to be solved again. That was a part of this, the answer. The other remark would be forgot it.
About Russia, Russia's proposed the backup DNS system.
I come to it back to it later.
Thanks. Alain Durand is next.
Thank you. I would like to address a point about the developing countries, developing economies, and also follow up on what Adiel was mentioning, some of the projects that we had started at ICANN. And so we started in October a research project with the Cabase organization in Argentina and the University of La Plata. And it's essentially evolving the DNS to use non-semantic identifiers to have persistent identifiers for IoT. And we did that in 3 weeks. But what I saw was the appetite for this type of technology over there. And then I went to the Afriniki in Nigeria just 2 weeks ago, and I met with people who were also very interested, and we are going to start another collaboration maybe in Ghana in January next year, like in just next month. And we expect to go about as fast in just a few weeks' time, get something up and running that is fairly easy, that doesn't require expert knowledge in a completely new technology, so that people can appropriate themselves and really start doing something that solve an actual problem that they have using technology that is readily available. So, thank you.
Thank you. Olga, for a comment?
Thank you for bringing this up. I know about this experience. It was an idea of our National Chamber of ISPs, Cabase, with the University of La Plata, as you rightly mentioned, and ICANN. I fully agree, and as I said before, I see the only way forward towards embracing any new technology or any new identifier scheme is through a collaborative effort in between business, ICANN, organizations like ICANN, universities, and associations like the Chamber of ISPs. My concern is that at a point it has to this evolution has to go down to the companies, to the smaller ISPs, to the smaller companies that are using the technology for perhaps identifying objects in their crop fields or catering. So I see that as a big challenge. I'm not saying that it's impossible, but I see it a challenge. Also, there are some challenges related with regulations which are different in every country. For example, using of a spectrum, and it's not the same in every country, could be not the same. So there are some things that should be harmonized. And, not many developing countries are active in ICANN. So I think that's good. Perhaps Argentina is a quite active country in ICANN, but not all the countries are even represented in ICANN. So I see the challenge there. And also the challenge I see is the rapid evolution of all the new disruptive technologies like artificial intelligence, Internet of Things, and other things are evolving more rapidly than before, perhaps IPv4s, IPv6, and the DNS. So this is what I wanted to. But thank you for bringing this up.
Thank you, Olga. Do we have any remote participants wishing to have any questions? Nothing at all, Aidan. Okay, not yet. All right. Let's go over to the gentleman in the back, please.
Ted Hardy from the Internet Architecture Board, and I wanted to respond to a point that was raised by Walid and related a bit to a broader point. And I wanted to reference RFC 2826, which is a statement by the IAB on the value of a unique DNS route. And in a lot of these identifier systems, it's not that they require a common resolution mechanism, but that they require that there be a single mapping between a particular identifier and the things which it resolves to. And we talk about that as the uniqueness principle in terms of the DNS. There is a single route to the DNS, and so there's a single administrative hierarchy which goes out. you can resolve from that single administrative hierarchy in any way you like. Indeed, we're developing ways for reaching DNS servers over QUIC and other transports that would change in some ways the mechanisms by which DNS resolution occurs without actually changing that uniqueness principle or without actually changing the mechanisms by which the administration works. And I believe that that's a very important principle for many Internet identifiers. It's certainly critical for IP addresses that there be a single holder of a particular IP address. And it enables you then to build identifier systems on top of it. It becomes a generative aspect of things, and we've certainly seen that in the DNS and its ability to generate things like URLs and URNs. And certainly we use then the scheme of the URL HTTP or DNS or whatever to disambiguate between the usage that we're going to put that to, but we rely on that uniqueness principle in order to build that generative system. And when I see something like DOA, which I consider a type of URN system, it operates slightly differently than the one built in the IGF, but it creates the same generative mechanism. The handle system isn't a single identifier system. It's a method for creating new identifier systems that work in a common way. And I think as long as that system maintains that same uniqueness principle, so that there is a single root to it and a single place from which they are generated, then it can be among the same identifier systems. It can function in the Internet in the way these other identifier systems can, and we can build on top of it the things which are appropriate to the kind of more complex schemata that it might be able to produce. And I'd also like to point out that there are sort of resonances here where our colleagues at schema.org have built something called iot.schema.org to take IoT schemas and ontologies to help you contextualize those, where the transparency of the information and the extent to which you've made it public is also a part of how generative it is in terms of people building systems on top of it. And so I think we look at those aspects of identifier systems and say, what is it that makes a great identifier system for the Internet? It's the uniqueness principle that enables it to be generative, and it's the transparency of the data it provides. And in that context, I think there are a raft of different identifier systems already on the Internet at a variety of levels, but they rely on those principles in order to function correctly. And I think we'll continue to rely on those principles as we build new identifier systems as the Internet changes and grows. Thank you.
Thank you, Ted. And as a follow-up, is there a danger of having a multiplication of competing identifier systems?
I think that the question kind of comes down to one thing. Is somebody who wants to be able to communicate with another node on the Internet going to be able to determine correctly how to do so from the systems which are provided to it? And as long as it's clear which system it uses for resolution and transport, then the danger is really one of deployment, not of architecture. And so you may have a small-scale system which can't handle a multitude of different resolution systems, and it will have to pick one. And in that, guys, I think you do have a bit of a deployment challenge in determining which resolution systems are appropriate to which system and which ones get deployed. And the simpler you make this, that is, the fewer you actually need to deploy, the more successful it will be. But this isn't really fundamentally different than deciding whether an IoT device needs 802.15.4 or 802.11. It's really a deployment question rather than an architecture one.
Okay, thanks for this, Ted. Now, I might have missed a few hands around the room, so I've got one, but Marco wanted to speak, so Marco Huguenet.
Yeah, thank you. Well, Ted already took away a lot of my comments in that and what I said in earlier on as well, is we should not forget sort of the layered architecture of the Internet, the fact that a few basic protocols allow you to invent and build new applications. In that sense, as Ted says, it also allows you to build new identifier systems to be used in those applications. But more to the comment to the exchange between Olga and Alain, while I appreciate these efforts, what I often see, and it's not particular to your solution per se, is that often the new solution is lacking a clear problem statement. What's the problem you're trying to solve here? And again, as I jokingly said, let's put it all in the DNS. And I sometimes have the feeling that we also put all problems in the DNS. And as a root server operator, sure, we have our set of problems, especially in developing countries. And we did a lot of effort in shrinking down our root server deployments to the point where we can now kind of host it indeed from the kitchen cupboard and no longer need like a fully equipped data center with 24/7 power, etc. We've come from a long way. We've responded to those problems. If you give us a problem statement, we can solve it. Or maybe we say, sorry, we can't solve it. This is a different layer. This is a different thing. And take that advice. Take the internet as an open model. Build something new. And we shouldn't immediately see that as a threat. We can also see that as an opportunity.
Thank you, Marco. As we've just expelled our session organizer and replaced him with Vin Cerf. Welcome, Vin. Let's go for the next question, please.
Thank you. This is Iftikhar Shah from Pakistan. This is a very good deliberation and discussion on the role of DNS in smart governance. Speakers highlighted the challenges to DNS, particularly the security, reliability, and accessibilities. Olga also highlighted the challenge of the implementation of IPv6 transition, particularly in the developing countries, and the use of SMEs in emerging technologies. My question is about how to, of course, there are some socio-technical challenges to address these key issues regarding the role of DNS in smart governance. My focus is the social aspect, and particularly the capacity building and awareness of the people of the community, particularly in developing countries. So, what is the strategy of the organizations like ICANN, ITU to address this issue? Thank you very much.
Thank you. Adil, do you wish to address this?
In terms of capacity building, we are talking about already existing and well, deployed identifier, right? So those identifier and capacity building around them happen through different organizations. I know the RAR, in terms of IP addresses, they are very active doing all kind of capacity building, and specifically for IPv6. And from ICANN perspective, we are also pretty much engaged into, for instance, securing some aspect of the DNS with DNSSEC capacity building around the world, and different other capacity building in how to use them, to use those identifiers, which already exist. I mean, that's where, because what is emerging is still emerging, and capacity building in there will come with the maturity of the new identifier system. But those who already exist, think from those two perspectives, there is a lot of work that is being done, and specifically in developing region as well, with Afrinic, AFTLD, LACTLD, or LACNIC as well, very active in those specific area. But to come back to the discussion about the evolution of the DNS, I just want to also highlight the fact that one aspect that will ensure that the evolution happen in a coherent way is also looking at the policy impact, or the impact of policy on those new identifier, or the way they are mapped, either through the DNS or any other architecture. How do we make sure that the policy that are put in place, or how our policy environment and the policy evolve, really address the issue that those new identifiers are posing? And that is key, because the technology is one aspect. I mean, what we are doing, for instance, is agnostic of the policy. It's just the technology, looking at it. But then, how do we implement it? What are the underlying principles that govern that? Is a completely different debate and discussion.
Thank you, Adil. And Christoph, from a donor foundation perspective.
I will just talk a little bit about our MPA experiences around the world. So they came to us with the idea of managing their own namespace and identifying their own resources and coming up with their own plans for how to deal with concrete problems that they're experiencing in their societies. And the big sell for them was that they had full control over their identifier space. Donna credentials them, but once they're credentialed, they can do whatever they want. We can see what they're doing, but we can't change what they're doing. And so for them, this was a big advantage, is that they could really decide how their policies would apply. And then the other thing that was very attractive is that they could manage the code themselves. They could decide to implement the handle system on top of whatever they wanted. They could redistribute the code. They could develop programs in their own countries to really make this part of their technological foundation. And that was the other thing. And not to say the DNS doesn't do this, but in the case of the DOA, we're not just talking about identifiers. We're talking about what do we do with the data. And I think this is the other part that they're interested in, is we want to talk about the data. We want to interact with the data, and they felt the handle system provided the level of accessibility, manageability, and technology transfer they were looking for. Thanks.
Thank you. We've got Hans-Peter, but I've had Andrew Sullivan waiting for a long time at the back. But perhaps if it's just on this thing, Hans-Peter, you wanted to say just a couple of words, Adil, and then we'll do... we'll go to Andrew, and then Vint will acclimatize to the mood in the room by then, hopefully. So, Hans-Peter.
Just a quick answer to it. To my feeling when I hear that's a big chance, that's a key point of selling it, that you have your own jurisdiction over your namespace, that's also a big challenge. Because it's not only what you allow to be entered into the namespace, it's also who is allowed to access this data and at what level this allowance is done. Everything is left to the one who is owning this part of the data space. And I think that's a big difference to the DNS. The DNS is always open for everybody, and the DNS gives answers to everybody who is asking without looking where you are coming from and what you are. And I think that's not only a pro, that's at the same time a big contra for the same thing.
Adil?
So just
and
like
Christoph, it's going to get warm now.
Sorry, no, it's just I don't have any specific issues with this comment. It's just it's not the technology that sets the policies. The handle system and DOA are open as you want to make them, and you can close them if you like. But again, I mean, you go to China and you can't get Google. So, and this is just a fact of life. You give the technology and you hope that they'll make the best of it, but you can't tell them how to run their stuff. I mean, you can, but they might just implement their own.
They might ignore you.
Oh, they might ignore you, exactly.
We might need to get someone from Google to comment on this. Adil? No? Okay, let's go to Andrew Sullivan, please. And apologies for making you wait so long.
No, I'm happy to wait. My name is Andrew Sullivan, and I don't speak for anyone. That's actually an important thing for me to say, but yeah, not even for myself. One of the things that has troubled me a little bit about this discussion, and it's not only in this room, but actually historically, is that there's very often an assumption that we need to specify the identifier system or some tiny set of identifier systems that are necessary for the Internet. And I think that that is not consistent actually with the history of the Internet, which had identifier systems from the very beginning that competed with one another, and various ones were used for specific sorts of cases, or they were appropriate for this use and not for that use, and so you use the new one when it's handy. And I guess the question, I think that this becomes a little bit more troublesome in an environment where we have the ability, to sort of suck up all of the data ever about everything that happens. Because in an environment where that is true, and there is this pressure to go to a single unified identifier system for, I don't know, airplane parts and shoes, it seems to me that that's actually a dangerous thing to be promoting. That is, I want to be able to find the entire history ever of what happened to the fan blades in the engine for the airplane that I'm getting onto. I think that's a fine thing to be able to do. I do not want the identifier of my shoes to walk out of the store with me and track me everywhere I go. And that seems to me to be a problem with a unified identifier space that is an important one. It has these big social and political consequences that are, from a technical point of view, with, putting my technical hat back on, I don't care. Like, it's just an identifier. Use it how you want. But as a citizen, I'm deeply worried about that pressure. And I think that we ought to be tackling some of that here in an environment where the policy and technical questions can both be on the table at the same time. We better be paying attention to the policy implications of that second thing. Thank you.
Thank you, Andrew. Vincerf? Now's probably the right time for you to come in.
I have to say I'm wandering in the midst, obviously, of a lengthy discussion, and I can't stay very long because I have another commitment in a few minutes' time. Let me start out by reinforcing something that Andrew said, which is that in the design of the Internet, our intent was there was freedom to invent identifiers that could be associated with IP addresses. And that it didn't matter whether it was DNS or something else. Now, it happened that DNS was invented in order to do something better than the host.txt file, which became unwieldy, both in terms of size and maintenance of its accuracy. So DNS had some very valuable properties, and of course it has expanded over time. In some ways, I think the DNS system has become overloaded with functionality that should cause us to think again about possible alternatives. It also has the property that at least the URLs that are derived from domain names are not permanent. They're not persistent. They have understandable features. For example, if you don't pay your rent, the domain name may go away, in which case the thing that it pointed to may also be inaccessible. Page not found being a common web-based error message. There's also the case that identifier systems in the Internet are already quite fragmented. We have private identifiers, hashtags, for example, or Facebook IDs and the like. And the fact that there is fragmentation isn't necessarily bad in and of itself. Andrew's point, I think, again, is worthy of consideration. So this existence of multiple ways of identifying things has already evolved. I will say that our inability to combine the various identifier systems into a more coherent whole is sort of sad from the purely technical point of view, but it may be inevitable from all the other forces that create that. I will say, and I spent an entire day with John Clenson and Patrick Feldstrom trying to sort through internationalized domain names and the awkward way in which we have tried to implement them using IDNA 2003 and subsequently IDNA 2008. I think our theories behind the use of Unicode to achieve this objective have proven not to be exactly valid, and so there's an issue there. How do we accommodate strings that are not in simple forms like ASCII? I don't think that we've done a very good job of that. And with the emergence of emojis and other things, I confess that it feels like the namespace has become weirder than I ever anticipated that it would, if that's a technical term. I'm also very concerned about TLD squatting, that is to say people using what look like top-level domains which are not. They're not part of the DNS. They get resolved in some alternative ways. And it causes problems if any of those TLDs actually become allocated in the domain name system. We have collisions. We already see this in .home, .corp, .local, and things like that. The monetization thing is very interesting. I had not anticipated any of this. The idea that a domain name is worth millions of dollars just didn't occur to me or John Postel or anyone else, I think, in the early stages, and we just gave them away. I guess if had
you kept them, you wouldn't be here. You'd be somewhere really warm.
Yeah, it occurred to me that a /8 should have been allocated to me personally before I left ARPA, and that would have been my retirement plan. But we didn't anticipate even the IPv4 gray market. We thought, 10 to the 32nd, 4.3 billion terminations was more people than there were in the world at the time. So here we are. I'm a big fan of IPv6 because it's got lots of space. So there's also one other really awkward problem, and I think it was hinted at earlier, and it has to do with semantics. These strings that we use for identifiers have meaning in many cases, although an identifier shouldn't necessarily be a word. In many cases it is, and that makes it easier to remember. The problem we have is that because there are semantics, people have reactions to the presence of some of these identifiers and their use. And from a purely technical point of view, it would be nice if the identifiers were just sort of plain numeric strings that nobody really cared about. However, nobody can remember them. And so we have this tension between something which is non-controversial and something which is useful. And now, how do we find a binding between those two? So let me finish, given that I'm consuming a lot of your time here, with an observation. I think that we surely should examine alternative identifier systems. We can ask ourselves, what properties would we like them to have, both technically and perhaps from the it's not just technical, but monetary. How do we maintain a system over long periods of time? If we want identifiers that last for a long time and can be resolved for a long period, I'm talking about hundreds of years, you have to have a business model that makes sense. So we should be asking ourselves not about the sole single new identifier system that we should adopt in the internet space, but rather what properties do we want our identifier systems to have, and then how do we craft those systems to produce those properties. And so despite the fact that it's a little unsatisfying to have more than one kind of identifier space, we live in that world today, and I don't think we'll escape it, so why don't we design our way into it? I'll stop there.
Okay, thank you very much, Vint. We have actually passed already the official end of this session. I've checked there is no other group after us in this room today, so we might be able to say just maybe closing words from each one of our panelists. And I'm really sorry we couldn't have 90 minutes because it really is now that we're starting to be in the, it's too crunched, too fast. Let's start with the furthest person on the table, and that's Hans-Peter.
That's the farthest out person on the table. Okay.
Was that south or north?
There's Jörg beside me, by the way.
Oh, I didn't even see Jörg. Okay, no, but Jörg finishes everything. Okay, go ahead, Hans-Peter.
Thank you. I really believe, to make it very short, we should stick to the principles. Let's grow as many flowers as there can be, because there are many good potential ideas floating around. And really, there need to be more than one solution, because we have several problems on the table, and there is not a clear one solution to all of them.
Marco.
Yeah, I think I agree with Hans-Peter there. There is certainly not a single solution for all the problems we can see, and especially as we start interconnecting them, we're just growing the problem space beyond this. So I'm also with Vint and a couple of other speakers, look at the problems and figure out a way to solve a particular set of them. But let's not try to agglutinate it all into one big space, because I don't think we'll manage that.
Ideal.
Yeah, definitely we need to look at what issue we're trying to solve, and as technical people focus on that and try to solve them. I will also add that there is a likely chance that the semantic aspect of name in the DNS is going to evolve, and that aspect may have less precedent in the naming system in general, which may push the DNS to work differently, and we have to look at that as well, anticipate that, and make sure that policy-wise and the way we use it matches what is coming up.
Christoph.
So I'm going to try to add something different, since I agree with everything that's been said here. I think some of the requirements that we should be thinking about in terms of these identifiers, and I call them resolution services as opposed to identifiers, because we should allow all of them. We need to think about security really seriously at the level, at the granularity of the identifier itself. And what is it that you're identifying? And how do you know that this identifier is actually referencing the item that is claiming to be an identifier for? And this is a key aspect of the handle system that was built in from the beginning, because that was our concern. Then the other one is we should try to think about ways to interoperate, because we might not need 80% of another resolution system's functionality, but we should be able to interoperate on the 20%, which enables 80% of the functionality. So that would be my comment. Thank you.
Thank you, Christoph. Olga.
Thank you. And being a very optimistic person, in spite of the fact that I have been talking about several challenges for developing countries, I do trust in the Internet Governance Forum, in the Regional Internet Governance Forum, National Governance Forum, ISOC, IGF, ICANN, in working with developing countries, developing regulators, in trying to bring all this new evolution of technology to all the world, so we have this Internet open for everybody, and especially for developing countries. Thank you.
Jörg?
Okay. So honestly, I was hoping that that panel would lead to some more answers as to whether we need or we would not need new identifiers. I see there could be a need for new identifiers, but we have to figure out what they would be used for. I would be very, very interested in what the point I wanted to raise before with your question, how we would make those identifiers interoperable if we would have more than those, or more than DNS, how that would interact and how we would migrate with something like DOA or blockchain or whatever comes up. I think that answer probably that is should be left to the next panel or us working on those identifiers. With that, I would like to thank Olivier once again for stepping in for Wolfgang. Very great job, and thanks for your attention. See you. Bye-bye.
Thank you very much, Jörg. I was just going to say, you touched on the multiplication of identifiers that could lead to user confusion. This was actually something that was discussed when the new GTLD program was put there, as how many more top-level domains would there be, how confused would people get. So now we've got top-level domains plus other identifiers plus IPv6, which makes it even more confusing on everything else. All right, thanks everyone for coming to this session. I hope it was interesting. And as you can see, we've got probably a title for the next session next year. So thank you, and this session is now adjourned.
I mean, that's because it's started because they found we can do it out. But it was ready 5-6 years. We need to make our That's what I tried to swear today. Adapt existing else. Or I built something that doesn't look like do you have a vision? They might be late at night. Some of the best ideas are the ones that. How do you think the idea of doing working in the internet was a bit of light, and it's like, man, it's like, oh, we have this, like this, well, there were. And now. Yeah. I live in my friend was about I don't I work for Dimes. I remember I know that. So I read like yes, parallel. So far it was like yeah, he said like yeah, we still don't know. Or you really don't want to go? I have a lot more evidence. No, I'm sure you do. Actually, I would rely on well, you can say major. I don't know. I don't know if you don't talk about breadcrumbs.